Hello students, welcome. Our today's topic is a relation between electric field and potential gradient, और कई बार ये बिल्कुल सिंपल पूछा जाता है, प्रूव दैट E इक्वल टू नेगेटिव ऑफ dV अपॉन dr, यानी इलेक्ट्रिक फील्ड इज इक्वल टू नेगेटिव ऑफ rate of change of potential gradient. So we will discuss potential gradient as well as the relation between the electric field and potential gradient. So let us start. So suppose let a positive charge Q be placed at point O as shown in figure. ये जो डायग्राम अभी हम कर रहे हैं, दिस डायग्राम we have already studied when we have calculated electric potential. So that is this is the same diagram. This is a positive charge, so you know the electric field of this positive charge is radially outward in this case, right? Now suppose you are bringing a test charge Q naught from infinity, right? क्या कर रहे हैं आप? एक टेस्ट चार्ज Q नॉट को इन्फिनिटी से सोर्स चार्ज Q की फील्ड में ला रहे हैं. सपोज करो यू आर एट पॉइंट P, you are bringing test charge Q naught from infinity and you are at now point P. So at point P, let E be the electric field, E be the electric field due to your source charge Q, and you know that electric field we have already derived the formula for that electric field. Now displace test charge Q naught from P to Q through a small distance, or you can say displacement dr. यानी Q नॉट को आप इन्फिनिटी से जब लाए तो आप कहाँ पहुंच गए थे? पॉइंट P पे, राइट? और P पे जो इलेक्ट्रिक फील्ड है क्या है? रेडियली आउटवर्ड, क्योंकि ये पॉजिटिव चार्ज है. पॉजिटिव की इलेक्ट्रिक फील्ड रेडियली आउटवर्ड होती है इस साइड. अब आप क्या कर रहे हैं? इस Q नॉट चार्ज को P से Q तक आपने डिस्प्लेस किया, और इसके बीच में जो डिस्टेंस है वो कितनी है? dr. So you are displacing in this way. So you can see the angle between the electric field and the displacement is what here? 180 degree. यानी जो इलेक्ट्रिक फील्ड थी आपकी वो कहाँ से? फ्रॉम योर लेफ्ट हैंड टू राइट हैंड, रेडियली आउटवर्ड. और आप चार्ज को कहाँ ला रहे थे? फ्रॉम योर राइट हैंड टू लेफ्ट हैंड. सो दोनों की जो डायरेक्शन है वो अपोजिट है, और एंगल हो गया 180 डिग्री. So work done. So work done to displace charge test charge Q naught from P to Q. It should be capital Q here. So work done, small work done, dW. You know work done is the product of force and displacement. So what is the value of F? You know from the electric field intensity, the force per unit test charge. So from here force equal to Q naught E. So put the value here. So dW Q naught E dot dr. Here it is not we are displacing from P to Q, so displacement is dr. So we will write here dr vector. Now Q naught, it is a dot product, so we will write it as EdR cos of 180 degree. By 180 degree you can see the direction of electric field radially outward and the displacement of charge, test charge from P to Q, that is opposite to electric field. So you know cos of 180 degree, that is -1. So क्या आ जाएगा आपके पास minus Q naught EdR. So this is the small work done in displacing a charge from P to Q. Now you know this source charge Q will have the potentials at point P and Q. Why? You know the potential has a relation V equal to 1.4 pi epsilon 0 Q upon R. Now P lies at a larger distance from Q. So P पे पोटेंशियल होगा कम और Q पे जो पोटेंशियल होगा वो होगा ज़्यादा, क्योंकि Q पॉइंट जो है वो सोर्स चार्ज से नियर है एज कंपेयर टू P. सो लेट dV with the potential difference between point P and Q. So now we have studied the formula or the derivations of potential difference. What was that? Potential difference was the amount of work done to bring a positive charge from one point to another. dW equal to work done per unit test charge. So from here you can calculate the dW, that is the small work done, and that is what Q naught dV. Let this be question number 2. So while making notes, this is your rough work, should be clear to you. So now this is also the work done, this is also the work done. So from these two equations आप इनको इक्वेट कर दो, from equation 1 and 2. So क्या आ जाएगा आपके पास minus Q naught EdR equal to Q naught dB. Q naught cancelled out, but is left EdR equal to dB. So from here E equal to min negative of dB upon dr. So now we have completed our work, that is to drive the relation between the electric field and potential gradient. Now so dV upon dr, what is this? dV upon dr is a rate of change of potential, with distance is called potential gradient. So this should be clear to you. Potential gradient है क्या? So potential gradient is a rate of change of potential with distance is called the potential gradient. और जो हमारे पास रिलेशन आया उसका मतलब क्या है कि इलेक्ट्रिक फील्ड इज इक्वल टू नेगेटिव ऑफ रेट ऑफ चेंज ऑफ पोटेंशियल ग्रेडियंट, राइट? व्हाट इट मीन्स, ये जो आपके पास नेगेटिव साइन है, व्हाट इट से, फर्स्ट वन, सेकंड पॉइंट, नेगेटिव साइन का मतलब क्या होगा? नेगेटिव साइन क्या इंडिकेट कर रहा है? नेगेटिव साइन इंडिकेटिंग दैट पोटेंशियल डिक्रीजेस इन द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड. Potential decreases in the direction of electric field. What it means? Yani, if you are going in the direction of electric field, suppose this is your charge, source charge, right? You are at point P, right? So if you are going toward the direction of electric field, what will happen? Distance from source charge will go on increasing. So as the distance will increasing, your potential will be decreasing. Why? Because you know the potential has the formula 1.4 pi epsilon 0 q upon r. It is inversely proportional to distance. So if you are going toward the direction of electric field, right, potential will be decreasing. This is the importance of negative sign. Now from this relation you can also find the unit of electric field. So what from here? E equal to dV upon dr in magnitude. So dV yani potential difference, you know potential difference has the unit volt. Dr yani distance, so volt per meter. So electric field has another unit, that is the volt per meter. So hope आपको अंडरस्टैंड हो गया होगा. So thank you very much. See you in the next video. So तब तक के लिए अगर आपने चैनल को सब्सक्राइब नहीं किया है तो आप जरूर कर लें और वीडियो को लाइक और शेयर जरूर कर सकते हैं. Thank you very much. See you in the next video.